Okay, so we're getting into our last few topics for Unit 3. The first thing we're going to talk about today are called complex fractions. And as I've warned you guys before, we've been making fractions more complicated as we've gone through the entire semester. We started out working with just regular fractions as coefficients. Then we moved into having fractions that contained the exponents in them. And then we just finished doing rational expressions, which are fractions with polynomials in them. So the last thing that I'm going to do is I'm going to make these complex fractions, which are fractions with other fractions inside them. So as you can see here in this example, okay, I've got 1 plus 3 over x. So my numerator has a fraction in it. And then in my denominator, 1 over 5x plus 2x plus 1 over x squared actually has two fractions inside of it, okay? So the issue is we may be given a complex fraction to start with, but we really never want to try to work with something like that. So what we're going to do is we're going to try to turn our complex fraction into a regular rational expression or a regular fraction. So there are two types of complex fractions that we work with. The first one I'm going to show you is what I call a tame complex fraction. Okay, that means that we have no more than one fraction in the numerator and no more than one fraction in the denominator. Okay, and the thing is about a tame complex fraction is it isn't even really a complex fraction. It's just division in disguise. So let's take a look at a couple of examples here. So in this first one, I have in my numerator 12x squared over 5y. And then in my denominator, I've got 8 times x to the 6th over 9y squared. Here is the key to keep in mind here. This line of my complex fraction, all that line means is division. So this complex fraction is really just a division problem, and we've just gone through doing those types of things. So I can rewrite this complex fraction as 12x squared over 5y divided by 8x to the 6th over 9y squared. Now that it's just a rational division problem, okay, I'm going to follow my keep, change, flip. Okay. So remember that from our last lesson. So keep, change, and flip. Okay. And that's going to mean that I'm going to take my 12x squared over 5y, write it exactly the same, change from division to multiplication, and then flip my second rational. So 9y squared over 8x to the 6th. Now that I've done that, I can go ahead and cancel everything that I possibly can. So 12 and 8 are going to help me cancel because 4 goes into 12 3 times and 4 goes into 8 twice. Okay. The next thing that I have is my x squared on top. So x squared on top can cancel with 2 of the x's and x to the 6th, leaving me with 4 of them left over. So now I have x to the 4th. 9, okay, 9 unfortunately can't cancel with either 5 or 2. Okay, so I'm going to leave that there. And then finally, I have the y squared can cancel with the y on the bottom. So the y on the bottom goes away, and one of my y's in the y squared goes away. All right. So now I can take a look and see what it is that I have left. So I have a 3, and I have a 9, and I have a y in my numerator. In my denominator, I have a 5, I have a 2, and I have an x to the 4th. Okay, so I'm going to go ahead, write all those together, and then multiply where I can. So 3 times 9 times y over 5 times 2 times x to the 4th. All right, and that's going to give me 27y over 10x to the 4th. And there is my simplified single rational expression rather than dealing with a complex fraction. Okay, so here's another one that I've got. 2x minus 10 over 4. And then that's in the numerator. In the denominator, I have x squared minus 5x over 3x. So again, I'm taking a look at this. The main fraction line here, okay, is going to represent division for me. So I can rewrite this instead of as a fraction as a division problem. So 2x minus 10 over 4 divided by x squared minus 5x over 3x. Okay. Now I'm going to keep change flip. So keep my first rational exactly the same. 4 times, change my division to multiplication, and then flip my second fraction. So 3x over x squared minus 5x. Okay. Now then, before I can go ahead and start canceling anything, I need to go ahead and try to factor my numerator right here and my denominator right here. So for the 2x minus 10, there's a greatest common factor of 2. And for the x squared minus 5x, I have a greatest common factor of x. So I can rewrite these as 2 times x minus 5 over 4 times 3x over x times x minus 5. Okay, now I can start looking at what I can cancel out. So first thing, the 2 and the 4 can cancel. I can simplify there. Next thing I have is the x minus 5 in the top and the x minus 5 in the bottom. And then lastly, I have an x on top and an x on the bottom that I can cancel. So what I have left, in my numerator, I have a 3. And in my denominator, I have a 2. So that whole complex fraction just turns out to be 3/2. And there's my answer.